As an introduction, as stated in earlier sections, logarithmic and exponential functions undo each other. This means that for each rule of exponent, there exists a logarithmic counterpart. In this lesson, we will cover the properties of logarithms. These can be used to help us solve more complex logarithmic and exponential equations. You will need to have these properties memorized. For example, because a to the 0 equals 1, it holds true that log base a of 1 equals 0. Similarly, as a to the first power equals a, log base a of a equals 1. And that's because a to the first power is always a. A to the 0 power is always 1. So to summarize this up, for any positive real number a, where a doesn't equal 1, it holds that log base a of 1 equals 0 and log base a of a equals 1. So those are your first two properties of logarithms. In the last section, we found that the inverse function of f of x equals log base 2 of x was f inverse of x, which is 2 to the x. In fact, in general, we can say that the functions defined by g of x equals log base a of x and h of x equals a to the x power are inverse functions. Knowing what you know about inverse functions, evaluate g of h of x and h of g of x. So let's do g of h of x first. So this is taking the function g and inputting h of x. H of x is a to the x power. So this gives us log base a of a to the x. Okay, so let's try to simplify this a little bit more. We know that since these are inverses of each other, that when I compose them, they're always going to equal x. So there's our first property. And now the other way you can kind of think about it is, remember, a logarithm is just a power. So a to what power is a to the x? Well, a to what power is a to the x? That has to be x. Looking at this other one, h of g of x, input g of x, so that's log base a of x. So going to h, we get a to the log base a of x. And then again, knowing that these are inverse functions, we know that when I compose them, you'll always get x as your answer. So that helps us with our second property. A to the log base a of x is always going to equal x. So far we have 4 properties. Let's just kind of put these right here so that we have them to look at as we're evaluating and using them. So the first one was log base a of 1 equals 0. Log base a of a equals 1. Log base a of a to the x equals x. And a to the log a of x equals x. So let's use these properties to find the exact values of the following expressions without using a calculator. What I really recommend you do is maybe watch me work through the first 2 and then pause the video and work through the rest of those yourself to see if you can come up with the same answers as I do. Okay, so log base 5 of 1. So this matches up with this first property. So that answer is going to be 0. Now again, if you don't remember that property, you can always think about it. Set that equal to x. So 5 to what power is 1? Well, the only way that you can have something equal 1 is if you're putting it to the 0 power. Or you could have just recognized this property here. Log base 2 of 2. So you can see this matches up with this property. Another way, again, if you didn't have this memorized, just think about it. 2 to what power is 2? Well, that's 1. Letter C. Log of 1. So log of 1 is log base 10 of 1. So you can see this matches up with that first property. So the answer is 0. Again, you can think about it. 10 to what power is 1? Well, 10 to the 0 power is 1. For letter D, this is the same thing as log base 10 of 10 to the 7th. So you can see this matches up with this third property. So that means the answer to that is just 7. Again, if you didn't have that property memorized, you could think about it. 10 to what power is equal to 10 to the 7th? well, it has to be 7. Letter E also matches up with that third property, so that's just 20. Letter F matches up with this second property because this is the same thing as log base E of E, so it's just 1. Letter G actually matches up with this fourth property because this is the same thing as E to the log base E of 5. So you can see we have the same base. So the answer to that is just 5. And the same thing happens for H because this is the same thing as 10 to the log base 10 of 3. So again, using this property, you can see the answer is just going to be 3.